High in our atmosphere, invisible rivers of air flow at incredible speeds. These are the jet streams, powerful currents that shape our daily weather. They guide storms. They influence temperatures. They help define the seasons. For all of human history, their general paths have been a reliable, if sometimes chaotic, constant. They shift with the seasons, meandering north and south, but always return to a familiar range. This predictability is a cornerstone of our global systems. From how we grow our food, to how we fly our planes, we have built our world around their expected behavior. But what if that fundamental constant were to change? Imagine a world where the jet stream does not return to its normal course. What if it were to lock into a new permanent position, significantly different from the one we know? This is not a question of temporary weather patterns or a single unusual season. Instead, we are considering a permanent alteration to one's Earth's most critical atmospheric systems. The change is locked in. The new atmospheric state is the new normal. The familiar weather maps of the past are now obsolete, pieces of a bygone era. This scenario poses one of the most significant challenges our interconnected world could face. The direct consequences would be immediate and profound. Areas that once received reliable rainfall might become deserts. Temperate regions could find themselves locked in persistent heat waves or endless winter cold. The very concept of normal weather would be erased, replaced by a new and initially unforgiving climate reality. The core question we must explore is not whether humanity could survive, but how it would be forced to adapt on a global scale. This is a walkthrough of what would happen, grounded in established science. We will explore the cascading effects of this permanent atmospheric shift. Our analysis will cover the immediate physical changes to our planet's weather systems. We will then examine the impacts on our critical infrastructure, the impacts on our global economy, and the impacts on the very fabric of our societies. We will follow the timeline of consequences, from the first days of confusion to the long-term adjustments years later, to understand what it would truly take for humanity to adapt. The jet stream is more than just a feature on a weather map. It is a vital component of planetary equilibrium. It's driven by the Earth's rotation and the temperature difference between poles and equator. That thermal gradient creates high-altitude winds that steer weather below. The jet stream's path dictates where rain will fall, where droughts persist, where agricultural breadbaskets flourish. Its stability links directly to our ability to feed billions. A permanent shift means a fundamental rewiring of global patterns. Compare normal agricultural calendar, chaotic, disrupted calendar with frost alerts and drought warnings. The initial impact hits the weather. Storm tracks would move. Some regions would be battered by constant precipitation. Others would be starved of moisture. That triggers a domino effect across systems. Global agriculture feels it first. Planting seasons become unpredictable. Frost in summer. Growing seasons cut short by sudden heat. Widespread crop failures. The aviation industry, which relies on the jet stream to optimize flight times and fuel consumption, it would face an unprecedented logistical crisis. Flights rerouted. Flights delayed. Air travel becomes more expensive overnight. Energy grids push to their limits as heating and cooling demands spike in unexpected places and at unusual times. New winners and losers emerge in months, destabilizing trade and economies. We'll take a realistic, evidence-based walkthrough. We will not engage in speculative fantasy. Instead, we'll methodically trace the cause and effect chains that would unfold. We will examine how our physical infrastructure, from dams, airports, we will analyze the societal pressures that would arise from food shortages, resource scarcity. A sober examination of adaptation, resilience, and vulnerability of global civilization. Table of Contents, Part 2. Act 1. Baseline Context. 1. The engine of the atmosphere. 2. A river of air in motion. 3. The science of a permanent shift. To understand the consequences of a shifted jet stream, we must first understand what it is and why it exists. The jet stream is not a single entity, but a series of high-altitude, fast-flowing air currents that encircle the globe. They are found in the tropopause, the boundary between the troposphere and the stratosphere, typically between 9 and 16 kilometers above the Earth's surface. Think of them as massive rivers of wind, often thousands of kilometers long, hundreds of kilometers wide, but only a few kilometers deep. Their speeds are immense, frequently exceeding 160 kilometers per hour, and sometimes reaching over 400 kilometers per hour. These currents are a fundamental feature of our planet's atmospheric circulation system. The primary engine driving the jet streams is the sun. The Earth is not heated evenly. The equatorial regions receive far more direct solar energy than the poles. This creates a significant temperature difference, or thermal gradient, between the warm air mass at the equator and the cold air mass at the poles. Nature constantly seeks equilibrium, and this imbalance drives a large-scale movement of air. Warm air from the tropics rises and flows toward the poles, while cold, dense polar air sinks and flows toward the equator. This fundamental process of convection sets the stage for the formation of the planet's major wind systems. However, temperature difference alone does not create the jet stream. The Earth's rotation plays a crucial role. As air moves from the equator toward the poles, it is deflected by the Coriolis effect. In the northern hemisphere, this deflection is to the right. In the southern hemisphere, it is to the left. This rotational force prevents the air from flowing directly from north to south. Instead, it channels the moving air into a relatively narrow, fast-moving band that flows from west to east. This combination of a strong thermal gradient and the Coriolis effect is what gives birth to the powerful high-speed winds we call the jet stream. There are 4 main jet streams on Earth: 2 polar jets and 2 subtropical jets. The polar jets are stronger and are located at a lower altitude, typically around 60 degrees latitude north and south. The subtropical jets are higher and weaker, found closer to the equator at around 30 degrees latitude. It is the polar jet stream that has the most significant influence on the weather experienced by populations in the mid-latitudes, North America, Europe, Asia. Its position and strength directly steer the movement of high and low pressure systems, dictating where storms form and travel across the surface of the planet. In the immediate days and weeks following the jet stream's permanent shift, the most direct and dramatic consequences would manifest in the atmosphere itself. The planet's weather-making machinery would be fundamentally reconfigured, leading to a period of unprecedented atmospheric chaos before settling into its new, harsh equilibrium. Storm tracks would be violently rerouted. Regions accustomed to regular precipitation, agricultural heartlands of North America, temperate zones of Europe could be bypassed. The rhythm of passing weather fronts would cease, replaced by unnerving stillness or a relentless barrage of storms. Fixed zones of extreme weather would form. Deep, permanent troughs would create continuous instability. Nearly constant cloud cover and relentless precipitation would follow, turning fertile plains into inundated swamps in weeks. Permanent ridges would produce dominant high pressure. Sinking air would warm and dry out, producing cloudless skies and no rain. Areas would plunge into perpetual drought, soil moisture evaporating and rivers shrinking. Regions would be locked into 2 states, too wet or too dry. The character of seasons would be warped. A permanent southward dip of the polar jet would let frigid Arctic air spill out, even in warm months, causing late spring or summer freezes that kill new vegetation. A poleward shift would block cold air, creating unseasonably and then permanently warm conditions. Gradual seasonal transitions, spring to summer, autumn to winter, would be replaced by abrupt static temperature regimes. The aviation industry would be one of the first global systems to experience a complete and immediate breakdown. New York to London, a flight that once rode the jet stream might now battle a crosswind or no wind at all. Tokyo to Los Angeles, a westbound flight that skirted the southern edge of the polar jet could be forced into its core. Airlines would be forced to ground thousands of flights immediately while frantically calculating new, safe, and economically viable routes. The economic fallout for the airline industry would be staggering and instantaneous. Waves of cancellations could last weeks as the global network is re-evaluated. Airports would become scenes of chaos with hundreds of thousands of stranded passengers. New jet stream patterns would create zones of extreme, previously unmapped clear air turbulence. This invisible turbulence can cause violent jolts to aircraft, posing a risk to passengers and crew. The era of routine, predictable intercontinental air travel would come to an abrupt and jarring halt, isolating continents in a way not seen in generations. Simultaneously with the atmospheric and aviation crises, a silent and even more critical disaster would begin to unfold in the world's fields. Global agriculture is a massive, intricate system built entirely on the foundation of predictable climate patterns. Farmers rely on centuries of accumulated knowledge about when to plant, when to expect rain, when to harvest. A permanent shift in the jet stream would obliterate this foundation, throwing the global food supply chain into immediate peril. In regions now under a persistent high-pressure ridge, the spring rains needed for seed germination would simply fail to arrive. In other regions, now trapped under a permanent trough, fields would be inundated with so much water that they become impossible to work. A permanent dip in the jet stream could bring devastating frosts to regions mid-season, wiping out entire orchards and vegetable farms overnight. The initial shock would lead to immediate spikes in food commodity prices on the global market, as traders react to reports of widespread planting failures. Nations that are heavily reliant on food imports would find themselves in a terrifyingly vulnerable position. The initial consequences in the agricultural sector would be the first step towards a global food security crisis, moving from the fields to the markets, and eventually, to the dinner tables of billions of people. The sudden and permanent alteration of regional temperatures would place immediate and unprecedented stress on the world's energy infrastructure. Transformers and substations, not designed for continuous peak load, would begin to overheat and fail, leading to cascading blackouts across major metropolitan areas. In places that rely on hydropower, a sudden drought caused by the shifted storm tracks could dramatically reduce reservoir levels, crippling their ability to generate electricity just when it is needed most. These energy failures would directly impact public health and safety. During the persistent heat waves, the lack of air conditioning would lead to a rapid increase in cases of heat stroke and heat exhaustion, overwhelming hospitals that are also struggling with power outages. In the newly cold regions, a failure of heating systems would result in a surge of hypothermia cases and deaths. The daily weather forecast, once a mundane part of life, would become a source of dread. This psychological stress, combined with the physical hardships, would begin to fray the social fabric, setting the stage for the more profound societal impacts to come. Table of Contents. Part 4, Act 3. System-wide Impact. Ecological boundaries redrawn. The economics of a new climate. Adapting infrastructure on a broken timeline. Human migration and societal fault lines. A new geopolitical chessboard. As the initial atmospheric shock subsides into a new, stable pattern, the medium-term environmental impacts become starkly clear. Vast landscapes transform. Forests turn to arid, dusty plains. The newly arid landscapes would become exceptionally vulnerable to wildfires. These megafires would rage for months, consuming entire ecosystems. The smoke from these fires would travel globally, affecting air quality thousands of kilometers away and creating a grim, hazy new normal for entire continents. In the newly drenched regions, the consequences are equally severe but opposite. Constant heavy rainfall would oversaturate the ground, leading to permanent wetlands where there were once forests. The runoff from these saturated lands would pour into the oceans, creating massive offshore dead zones where algal blooms suffocate all marine life. These changes would force a mass migration of animal and plant species, or, more often, their extinction. The intricate web of life would be torn apart, leaving behind a less diverse and more homogeneous biosphere. The initial agricultural failures would deepen into a permanent state of crisis. This would cause a sustained and catastrophic spike in the price of staple food commodities. Some previously marginal lands, perhaps in the subarctic, might suddenly find themselves with a viable growing season. The insurance industry would be among the first to collapse under the strain. Factories in newly arid zones would be forced to shut down due to water rationing. In new desert regions, cities would be forced into massive engineering to secure water. Desalination plants on an unprecedented scale. In the perpetually flooded zones, the task would be to manage a constant excess of water. Cities would have to be re-engineered with massive new canals. A shift towards decentralized, resilient microgrids would become essential. The scale of civil engineering required would be akin to a global perpetual war against the new climate, with every major city on the front line. The failure to adapt infrastructure quickly enough would inevitably trigger human migration on a scale never before seen. This mass movement of people would place unbearable strain on the social fabric of the destination regions. The response would likely be fractured, while others erect barriers and militarize their borders. The crisis would exacerbate existing inequalities, creating a starkly divided society of haves and have-nots. In the most affected regions, state authority could collapse altogether, leading to the emergence of failed states ruled by local warlords. Geopolitics would be recentered around a new set of fundamental realities, shifting the world's economic and strategic center of gravity poleward. The era of global cooperation and shared values would likely give way to a more ruthless zero-sum game of national survival. Disputes over shared river basins would escalate from diplomatic protests to military confrontations. Over the span of several years to a decade, the initial phase of chaotic survival would slowly transition into a more structured, long-term adaptation. In agriculture, this would mean a permanent and widespread adoption of new farming techniques and locations. In the most severely impacted regions, a strategy of planned retreat would be implemented, forcing relocation into more secure, consolidated urban centers. Social norms would evolve around resource conservation, with water and energy usage becoming strictly monitored and culturally ingrained. The psychological trauma of the shift would leave a legacy of generational anxiety and a collective memory of the world that was lost, profoundly shaping art, philosophy, and the worldview of those living in this new, harsher equilibrium. Decades after the permanent shift, a new global equilibrium would begin to take hold, characterized by a stabilized but starkly different world. Ecologically, the planet would be scarred but healing. New permanent climate zones would foster novel ecosystems. Ultimately, humanity survives, but at great cost. Civilization forced through a bottleneck, emerging leaner, harder, more centralized. The memory of the Great Shift becomes a permanent, humbling lesson, etched into the psyche of its inhabitants, who forever live in the shadow of the day. The wind changed its course. The scenario of a permanently shifted jet stream, while hypothetical, serves as a powerful educational tool, forcing us to confront the profound interconnectedness of our world. It teaches us that the invisible currents of air high above our heads are a fundamental anchor for our global civilization. By exploring the cascading consequences of altering just one variable, the jet stream's path, we gain a crucial insight into the systemic fragility of the world we have constructed. Realistic adaptation would involve monumental feats of engineering, a fundamental reordering of society, driven by sheer necessity. Ultimately, this analysis reinforces the critical importance of understanding and preserving the natural systems we depend on. The final educational insight is not one of fear, but of profound respect for the delicate equilibrium that makes our world habitable. Our world is a single integrated system, and its stability is the most valuable resource we possess. You've been watching IfVerse, where imagination meets possibility. See you in the next reality. What scenario should we explore next? Share your ideas below.